Brace yourself for a cosmic journey that will leave you speechless. The James Webb Space Telescope, humanity's most advanced eye in the sky, has turned its gaze toward Jupiter, and what it's revealed is nothing short of mind-blowing. Shocking images have unveiled secrets about the gas giant that are rewriting everything we thought we knew. From monstrous storms that could swallow Earth whole to mysterious auroras powered by forces beyond imagination, Jupiter is a world of chaos, beauty, and enigma. This is not just a planet, it's a celestial beast, and its secrets are more terrifying and awe-inspiring than anyone could have predicted. Hold on tight, because what you're about to hear will shake your understanding of the universe to its core. Picture this: a storm so colossal it makes Earth's mightiest hurricanes look like a gentle breeze. Jupiter's great red spot, that iconic swirling vortex, is a beast of unimaginable power. This isn't just a storm, it's a cosmic titan, with winds screaming at 270 to 425 miles per hour. That's 3.5 times faster than the most devastating F4 tornado on Earth. Its size? So vast it could engulf our entire planet with room to spare. For centuries, this scarlet monster has raged, a symbol of Jupiter's untamed fury. But here's the shocking twist. It's changing. The Great Red Spot is shrinking. Once stretching 24,000 miles across, it's now dwindled to about 10,000 miles. But it's not just getting smaller, it's wobbling, almost pulsating, like it's alive. Sometimes it contracts, sometimes it expands, as if the storm is breathing. Why? Nobody knows for sure. The jet streams tearing through Jupiter's chaotic atmosphere might be tugging at it, or the planet's intense internal heat could be stirring the pot. There was even a moment when chunks of the storm seemed to break off, drifting away like cosmic confetti. Some feared the Great Red Spot was disintegrating, but don't be fooled. This storm is fueled by an insane amount of energy. It's not going anywhere soon. It might morph, shrink, or grow, but it's likely to rage for decades, maybe centuries. This isn't just a storm. It's a reminder that Jupiter is a world of relentless, unpredictable power. But the Great Red Spot is just the beginning. The James Webb Telescope's infrared eyes have peeled back layers of Jupiter's atmosphere, revealing jaw-dropping details. Above the Great Red Spot, scientists expected a calm, uniform region, bathed in the faint sunlight that reaches Jupiter, only 4% of what Earth gets. Instead, they found chaos. Dark arcs and glowing spots pepper the area, defying every prediction. The images show blue regions at lower altitudes and red ones higher up, painting a picture of a storm with a complex, almost alien structure. Something else is at play here, something powerful enough to sculpt the atmosphere in ways we don't fully understand. One theory points to gravity waves, ripples born in the turbulent depths of Jupiter's atmosphere, surging upward like waves crashing on a cosmic shore. These waves, far stronger than anything on Earth, could be reshaping the planet's upper layers, creating patterns that dazzle and confound. Every new image is a puzzle piece, and Jupiter is proving to be far more dynamic than we ever imagined. Now let's talk about something that will make your jaw drop: Jupiter's auroras. On Earth, auroras are a delicate dance of light, sparked by solar particles tickling our atmosphere. But Jupiter? Its auroras are a cosmic fireworks show, powered by forces that dwarf anything we've seen. The telescope captured breathtaking images of these glowing spectacles shimmering at the planet's poles. Unlike Earth's auroras, Jupiters are fueled by volcanic material spewed from one of its moons, Io, a world so volcanic it's practically a furnace. This material, blasted into space, gets caught in Jupiter's magnetic field, creating auroras that blaze with an intensity 30 times stronger than Earth's. Imagine this: electrons screaming through the atmosphere with energies up to 400,000 electron volts, painting the sky with light that could outshine a supernova in its ferocity. And here's the kicker: every 27 minutes, Jupiter unleashes a burst of X-rays tied to its rotation and the solar winds slamming into its magnetic field. These X-rays light up the auroras, creating a spectacle that's both beautiful and terrifying. Jupiter isn't just a planet, it's a cosmic powerhouse, and its auroras are proof of its untamed might. Speaking of moons, Jupiter's satellites are a story unto themselves. With 92 moons, more than any other planet in our solar system, Jupiter is a gravitational king, ruling a court of cosmic wonders. The James Webb Telescope and the Juno probe, which traveled an astonishing 1.7 billion miles to reach Jupiter, have captured images that are nothing short of staggering. Take Ganymede, the largest moon in the solar system, bigger than Mercury. Recent images revealed something shocking: evidence of a massive asteroid impact, 93 miles wide, that struck 4 billion years ago. That's 10 to 15 times larger than the asteroid that wiped out the dinosaurs on Earth. The impact was so powerful, it knocked Ganymede off its axis, altering its rotation. The crater is mostly hidden, with debris falling back into it, but the scars are unmistakable. Ganymede's surface is a battlefield, pocked with craters from countless ancient collisions. But here's where it gets wild. Beneath its icy crust, scientists suspect a vast ocean of liquid water, frozen solid at -300 degrees Fahrenheit, but potentially harboring life. Yes, life. 500 million miles from the sun, this barren ice ball could hold the key to one of the universe's greatest mysteries. New missions are planned to dive deeper, and the possibility of finding alien life on Ganymede is enough to send chills down your spine. Then there's Io, the moon that's literally on fire. Covered in lava lakes and over 400 active volcanoes, Io is a hellscape that makes Dante's Inferno look tame. The Juno probe caught 2 volcanic plumes erupting, and new data revealed a massive volcano spewing material into Jupiter's magnetosphere. This volcanic chaos doesn't just stay on Io, it powers Jupiter's auroras, creating electric currents of 3 million amps that surge along the planet's magnetic field, igniting lightning and auroras in its atmosphere. Io is a cosmic generator, turning itself into a 400,000-volt powerhouse as it orbits 262,000 miles from Jupiter. Every image of Io is a reminder that Jupiter's moons are as wild and unpredictable as the planet itself. But let's dive deeper, literally, into Jupiter's core. For years, scientists believed gas giants like Jupiter had a rocky core, a solid heart buried beneath layers of gas. But recent data from Juno has turned that idea upside down. Jupiter's core is a mystery, and it's weirder than anyone expected. Using powerful lasers to mimic the planet's insane pressures, far greater than anything on Earth, scientists discovered that only 18% of Jupiter's core is rocky. The rest? A bizarre mix of hydrogen and helium, with 90% of the planet's composition being hydrogen alone. As you descend into Jupiter, the pressure transforms this hydrogen into something extraordinary: liquid metallic hydrogen. This isn't your average liquid, it's a dense, conductive fluid that acts like a metal, turning Jupiter into a colossal generator. Imagine a 40,000-kilometer deep ocean of this liquid metallic hydrogen spinning with Jupiter's rapid 10-hour rotation, generating a magnetic field that stretches 725 million kilometers, the largest in the solar system. This field is 20,000 times stronger than Earth's, but it's not stable. Scientists have discovered a strange region near the equator called the Great Blue Spot, a magnetic anomaly that acts like a second South Pole. Its strength fluctuates by up to 1% per year, and it might be linked to the Great Red Spot, which sits at the same latitude. Could these phenomena be connected? The Juno mission, extended to 2025, is racing to find out, but every new discovery only deepens the mystery. And then there's the Great Cold Spot, a massive region as large as the Great Red Spot, but 200 degrees Celsius cooler than its surroundings. Unlike the red spot, this feature is volatile, vanishing and reappearing over time. Scientists now know it's tied to Jupiter's auroras, which transfer energy to the atmosphere, creating a swirling vortex of cold air. This spot is thousands of years old, as ancient as the auroras themselves, and its existence proves just how interconnected Jupiter's atmosphere is. The planet's rapid rotation traps heat in specific areas, creating temperature contrasts that drive these massive features. It's a chaotic dance of energy, and we're only beginning to understand the steps. But here's something that will blow your mind. Jupiter doesn't actually orbit the Sun. Yes, you heard that right. Because of its immense size, 2.5 times the mass of all other planets combined, the center of gravity between Jupiter and the Sun lies just above the Sun's surface. Both the Sun and Jupiter orbit this point, called the barycenter, in a cosmic waltz. This makes Jupiter unique in our solar system, a planet so massive it bends the rules of orbital mechanics. Its size isn't just impressive, it's a game changer, affecting everything from the asteroid belt to Earth's climate. Speaking of Earth, Jupiter's role as our protector is under scrutiny. For years, astronomers thought Jupiter acted as a shield, deflecting asteroids and comets that could threaten life on Earth. The 1994 impact of comet Shoemaker-Levy 9, which slammed into Jupiter in pieces, seemed to prove this. But new simulations tell a darker story. Jupiter's gravity doesn't just eject space rocks, it can redirect them toward Earth. In 1770, Lexell's comet came within 1 million miles of our planet, a close shave caused by Jupiter's gravitational tug. While Jupiter does fling long-period comets out of the solar system, it also stirs up the asteroid belt, sending rocky fragments into resonant zones that increase the odds of Earth impacts. If Jupiter were less massive, it might destabilize comets without ejecting them, leading to even more collisions. Earth's geological record shows we can handle one major impact every 100 million years, but a higher rate could devastate life. Jupiter is both our guardian and a potential threat, a cosmic double-edged sword. And then there's water. In 1995, the Galileo spacecraft detected water vapor in Jupiter's atmosphere, and recent data from Juno and the James Webb Telescope confirmed it. Water makes up 0.25% of the atmosphere above the equator. That might sound small, but on a planet with more than double the mass of all others combined, it's an immense amount, far more than Earth's oceans. This water drives Jupiter's lightning 100 times brighter than Earth's and creates bizarre hailstones called mushballs. In the upper atmosphere, ammonia acts as antifreeze, melting water ice into droplets that collide with ice crystals, generating electric charges. These mushballs grow heavy and plunge deep into the atmosphere, a process unlike anything on Earth. Water on Jupiter isn't just a curiosity, it's a clue to how our solar system formed, and it might even hold answers to how Earth got its oceans. Jupiter's atmosphere is a kaleidoscope of chaos. The James Webb Telescope captured vivid bands of swirling clouds, cyclones and hurricanes, some interconnected in an atmospheric network that suggests a level of complexity we never imagined. At the equator, a 3,000-mile-wide band of clouds races across the planet at 320 miles per hour, faster than any storm on Earth. These features aren't just beautiful, they're a testament to Jupiter's relentless energy. The planet generates its own heat, radiating more energy than it receives from the sun, and this internal furnace drives its wild weather. Every image is a snapshot of a world in constant motion, a planet that never rests. But let's zoom out and consider what all this means. Jupiter isn't just a planet. It's a key to understanding our place in the universe. Its massive size and gravity shaped the solar system, preventing a planet from forming where the asteroid belt now lies. Its water, storms, and moons could hold clues to the origins of life. And its influence on Earth, from climate cycles to asteroid impacts, reminds us that we're not isolated. Every 405,000 years, gravitational tugs from Jupiter and Venus shift Earth's climate, bringing extreme winters, scorching summers, droughts, and floods. We're in the middle of one such cycle now, and any change in Jupiter's behavior could ripple across the solar system, affecting us in ways we can't yet predict. The James Webb Telescope and Juno probe are rewriting the book on Jupiter, but every answer raises new questions. Why is the Great Red Spot shrinking? What's driving the Great Blue Spot's fluctuations? Could Ganymede's ocean harbor life? And what happens if Jupiter's storms or magnetic field shift in ways we don't expect? These aren't just academic questions. They're about our future, our survival, and our place in a universe that's far wilder than we ever imagined. As the Juno mission continues and the James Webb Telescope captures more images, we're on the cusp of even greater discoveries. Jupiter is a world of extremes, colossal storms, alien oceans, volcanic moons, and a magnetic field that could power a star. It's a planet that defies every expectation, a cosmic enigma that challenges our understanding of what's possible. The images we're seeing aren't just pictures. They're windows into a universe that's vast, chaotic, and breathtakingly beautiful. So what's next for Jupiter? Will its storms fade, or will new ones rise? Will we find life in Ganymede's depths? And how will this gas giant shape Earth's future? The answers are out there, waiting in the swirling clouds of a planet that's as terrifying as it is magnificent. Stay tuned, because the universe is full of shocks, and Jupiter is just getting started.